Well, we're going to go ahead and have everybody back except one. But we're going to go ahead and get started since it is 8 o'clock. And so that we can get done early. Right? We like getting done early. Especially her. She is here. She said she has a 3-hour class. The one right before this in this room. She's in this room for 6 hours on Tuesday nights. How long would that be? What? For how many classes? Oh, that's too long. It would make me want to, I don't know, go drink a whole bunch of Dr. Pepper. That's what it would make.
8 hours a day?
Yeah, but I'm not in this. Well, I guess I don't even say room, but I mean, I'm not sitting in one class for like 3 hours and then another class for 3 more hours. Okay.
And you get paid.
And I do get paid. So you guys get paid by you're eventually gonna get this degree, and then you'll be like, haha, I got my degree. Well, make sure you pass then. Aren't you passing so far?
Yes.
Okay.
So far.
Okay.
What is 4 weeks? Is it 4 to 8 weeks? 8 weeks.
I don't know.
I don't know. This is my 7.
Is it 7? Okay. And 2 of those weeks, there's the last test, the last normal test, and then the final. So actually, like 5 weeks of actually doing it. You can't break. So those will be really short, right? Because the second to last week is just the test over, I think, chapter 5 or whatever, chapter 8, whatever it is. So that was just take the test and go home, and then you come back and take the final. I suppose we could study a little bit for the final if we want to. Okay, section 3.6, complex zeros. Okay, so we were just doing all the real zeros. The only difference that happens in these is sometimes we don't get all real answers, just like we don't get all rational. Sometimes we get complex answers, which that includes not just reals, but also what we call imaginary numbers. So the most basic complex number is I. Now, what does I stand for? Oh, that is not right. Hang on, I've got to fix this. I stands for, I'm missing a symbol here. I stands for the square root of -1. Now, you may remember back, we've talked about this before, you can't take the square root of a negative number, right? And, well, you can't take a square root of a negative number and get a real answer, because there's no number that you multiply by itself, there's no real number that you multiply by itself, and you get a negative answer. But there are situations where, in modeling different equations, different real-life situations, that you need to have these sort of numbers that when you multiply them by themselves, you get a negative answer. So, and they come up in polynomials sometimes too. So I is defined as the square root of -1. That is the simplest complex or imaginary number. Any real multiple of I is also an imaginary number. And so what you will see a lot of times, if you have a negative inside of a radical like this, that negative, you pull it out, and you just write down an I next to the radical. Okay? So instead of having the square root of negative whatever, we pull that negative out, and then we just have the square root of whatever it was left over. Okay, so anytime there's a negative inside there, -7, -12, negative whatever, just pull the negative out, and then you're left with the 7 or the 12 or whatever. Okay? And that works for any positive number A. So the first thing we're going to do is we're going to work on just some simplifying. How do we simplify this when there's this weird negative inside of it? And I'll wait for a second because I know I've got people writing stuff down. Are we good? All right. So I've got that property up there still. What do we get, or what's the first thing we do if we see square root of -8? From our property, we take an I out of it, and we write down square root of 8. Okay? Step 1, always do that first, get rid of the negative. Now, step 2, if we're going to simplify this and keep it as an exact answer, in some situations we'll type it into a calculator, right? But if we want it to be an exact answer, if you remember what we did, we started breaking down this 8. How can we break down the 8?
2, 2, 2.
Okay, he's jumping ahead. We'll say 4 and 2, and then 2 and 2, right? So this is 2 times 2 times 2. And do you remember what our rule was then when we had things inside of a radical like that? How could they get out? If we had a pair of them. So since we have a pair of 2's, that can come out, and so we'll have the 2 out there, and the I out there, and the square root of 2 left inside. And that's how we would simplify that square root of -8. Okay?
So out of the, how do you get the 3 2's out of that factor?
Out of the 8?
Yeah.
Okay, so we break up the 8 into 4 times 2. So 2 is prime, so we're done breaking that one up. Can't break it up into any other multiples. And then the 4 breaks up into 2 and 2, so that gives us,
So you put all.
we put all 3 of those 2's inside. All the prime numbers inside. Okay, this one's going to be easier. What do we do with that one? There's the first one. I squared root of 2. Can we break up the 2? No. So that's just our answer. I squared root of 2, and we're done. What do we do with the next one? I square root of 12, right? Now, can we break up the 12? We can certainly try. Let's try. 12 can break up into 6 and 2, okay? And 2 is prime. We can break up 6 again. 3 and 2. So what do we have inside? We've got I, and then we've got a 2 and a 2 and a 3. I like to put them in order, so I put them from smallest to biggest. So 2 times 2 times 3, and then we can see the pairs, right? We've got a pair of 2's. So the pair of 2's, that comes out, you've got 2 I, and inside you still have a 3. Okay? Make sense? Now the last one I think you'll really like. So what do we do first? Take out the I, and we've got square root of 36. Can we simplify the square root of 36? What do we know that the square root of 36 is? 6, right? So we're just going to have 6 with an I. Because the square root of 36 is 6, right? Does that make sense? Okay, that's a great question. Now, can I break it down so you can see it? Okay. Well, the easiest way to do it is 36, 6, and 6, and just be done. But if you didn't notice that, you can keep breaking up into 2 and 3, and 2 and 3. So you got a 2 comes out, a 3 comes out, and yeah, you multiply those 2 together. Okay. Oh, which one comes first? So usually we put the number first and then the I. Usually. But look over here. Here we've got a number and then the I and then another number. Okay. So we usually put the integer numbers in front of the I, and if there's still a radical, we put that after the I. Why? I don't know. Someone decided that somewhere along the line. I have a feeling it's because of this. If we're not careful, and we write 2 square root of 3 and then an I, if we're not really careful with where this ends, somebody might think the I is inside the radical or something like that. So that's my guess. But usually we put the I before the radical. Okay. So how is that? Yeah. No, because if there's more than one I, and I think we're going to get to that, you can always simplify it. Because I times I, square root of -1 times square root of -1 is just going to be -1, and then you're done. We'll get to that in a little bit. Okay? All right, let me erase this. Okay, complex number. And I mentioned complex numbers include real numbers and imaginary numbers. So we were just dealing with some imaginary numbers that have i's in them. That's what makes them imaginary. A complex number is a number that has this form, a plus b times I. That's standard form. We always want to write our answers in that form. Okay? A and b are real numbers. So when we write our answers, we'll always write it in that form. Real part, plus imaginary part times I. So let's simplify these. Simplify and write in standard form, which is, even if the directions don't say that, we're always going to do that. Okay? Then identify the real part and the imaginary part. So just so you know from up here, the real part is the A, where there's no I by it. The imaginary part is the B. Notice it's not the BI, it's just the B. The I just tells you which part is the imaginary part. Okay? So let's go ahead and simplify this. Let's start with this. What do we do first? Because that's a -9 in there. Take out the I. And then we like 9 because what's the square root of 9? 3. So this becomes 3i plus 6. We got to be careful though. We're not done yet, are we? Because we want to put it in standard form. Standard form says the real part goes first, imaginary part goes second. So this is a plus 6, so that's positive 6. This is a positive 3i, so plus 3i. That will be standard form. Okay, a plus bi. So what is the real part of this number? 6. What is the imaginary part of this number? Just the 3. And again, that's where we say the I just tells you which part is imaginary. It's not actually part of the imaginary part, which sounds weird, but whatever.
So that 3 is
No, the 3 is there. And again, I know people are like, oh, imaginary, it's not, it doesn't exist. That's not what it means. Think about things that are imaginary. They're not real, right? We've got real numbers, and then we've got imaginary numbers that are not real. So that's what we're talking. We're not saying they don't exist. They exist, but they're not real. Okay? All right. Let's see. Square root of -18. First thing we're going to do, pull out the I, right? Now, because I don't have much room on the bottom, let's simplify the square root of 18 over here. We can break that 18 up, can't we? Sorry? 2 and 9. And then 3 and 3. So we've got in here 2 times 3 times 3. What can come out? The 3. So this is going to be 3 square root of 2, right? Now when we go back here, it's 3i square root of 2 plus 7. What do we want to do before we say that we're done with our answer? Yeah, we want standard form, right? 7 goes first, plus 3i square root of 2 goes second. Now, what is the real part? 7. And this one might be a little tricky. What's the imaginary part? 3 and what else is by that I? Square root of 2. So 3 square root of 2 is the imaginary part. Okay? Everything over there by the I is the imaginary part. So does that make sense? Maybe? We'll find out. Okay. So there's your 2 answers, and that's what we got. And then we identified the real and imaginary parts. Okay? Are we good to go on?
The result of it is, for example, the thing just because of this turn off the men. And therefore women are more likely to be killed than men.
So now that we've discovered we have these complex numbers, how do we add, subtract, multiply, and divide them? Well, that's what we're going to do right now. To add complex numbers together. Do you see what is happening here? Real part, imaginary part, real part, imaginary part, right? What do we do with the real parts? We add the 2 real parts together, and that gives us the new real part. You just add the real parts together. And then what do we do with the imaginary parts? Add them together also, right? It's kind of like adding like terms, isn't it? You got like a 7i plus a 3i, you get 10i. Okay?
From Sweden over there, we ranked number one.
Oops.
82%, all the way down.
Are we good? All right, let's do some examples. I'll give you a minute to write those down if you want to, and then we'll go ahead and do some adding and subtracting. Now notice we didn't make up a rule for subtracting, right? Because when we subtract, we just add the opposite. So that takes care of it. We don't need a separate rule. So that first one says 3 minus I plus 2 plus 3I. Second one says 2I plus negative 4 minus 2I. The third one says 3 minus negative 2 plus 3I plus negative 5 plus I. And then the last one, 3 plus 2I plus 4 minus I minus 7 plus I. So on the first one, it's just addition, right? Let's underline real part, real part. We add them together, and what do we get? 5. So the real part is 5. I'm going to use green. This one, imaginary part, imaginary part. So we've got a negative 1I, right? There's no number there, but it's a negative 1I plus 3I. What do we get when we combine those? Positive 2I. Is it in standard form? Yes, it is. So as long as we just add the real parts first and the imaginary parts second, it'll automatically be in standard form. And that's our answer. We can't do anything more with that. When we go to the second one, real part. Where's the real part? Yeah, just negative 4. So we just write that down. What about the imaginary parts? Well, that's these two, right? 2I, negative 2I. What do we get when we combine those? 0. Now, just like normal numbers, what happens when you multiply anything by 0? You get 0, right? So 4 plus 0 is just 4. So we don't have to write plus 0I. We just write 4. It's understood that it's a 0I if there's nothing else written there. So there's our first one. There's our second one. Oh, wait, I missed the negative. Negative. Okay. Now the next one, we have to be a little bit careful, right? Because we're subtracting. Like I said, we didn't learn a rule for subtracting, but instead of subtracting, we're going to add the opposite. So instead of subtracting a negative 2 plus 3I, we're going to add a positive 2 minus 3I. Does that make sense? How you add the opposite? Or you can think of distributing the negative, however you want to think about it, but it changes those signs. Now, once we've done that, the real parts are 3, 2, and negative 5. So what do we get when we add 3 plus 2 plus negative 5? 0. So the real part here is 0. Then the imaginary part, I'm going to circle these, negative 3I and positive 1I. What do we get when we combine those? Negative 2I. So what would we say that our answer is? Do we need to write the 0? No, we just write negative 2I. Okay. Does that make sense? All right. Let's go on here. Let's take care of the subtraction first. Instead of subtracting this, we're going to add a negative 7 and a negative 1I. Negative I. Okay? So add the opposite. You just change all the signs. Real part, real part, real part. What do we get when we add all those together? Yeah, 3 plus 4 is 7, plus a negative 7 is 0. And then imaginary, let's see what we've got. Imaginary part,
because of the difficulty.
imaginary part, imaginary part.
And how-
What do we get when we add all those together? 0.
and you may think something-
So what would we say that our answer is? 0, right? Is it okay to add numbers together and get 0? Sure, like 7 plus -7 is 0, right? So that's okay, 0. So how's addition? Make sense? Okay. Any questions on these before we go on? All right. Okay, so we also multiply sometimes, right? And when we multiply imaginary numbers, here's what's going to happen. The first thing we want to do is simplify them if we need to. So remember this negative inside of here. What do we do? I, take out the I. And then what's the square root of 4? Yeah, so that's going to be 2I times. And then what about this one? Take out the I and square root of 16. And what's the square root of 16? 4. Now, when we multiply these together, we multiply the numbers together, and then we multiply the i's together. So 2 times 4 is 8, right? What happens when you multiply, and let's pause for a second on this problem, but what happens when you multiply x times x? What do you get? X squared, right? So would it make sense that when you multiply I times I, you get I squared? Okay, and that is what happens. You get I squared, I times I. Okay, but now we want to go over here to the side, and if you remember our definition, I equals the square root of -1. Here's what that means. That means I squared equals -1. It's like we're squaring both sides. Okay? So anytime we see this I squared, we replace it. And what do you think we replace it with? A -1. So this becomes 8 times -1. And what is 8 times -1? -8. And that is our answer. So you will never have an I squared or an I cubed or an I to the 4th. You'll never have that. The highest power you can have is just I. Okay? Now, how do we multiply this? Remember how we do that? We've got to distribute. FOIL. So 2 times 4 is 8. And then 2 times 3i. Now, remember, we multiply the numbers. So 2 times 3 is 6, positive 6. And then we've got the I sitting there, right? There's nothing else to multiply it by. Now, this, remember, is a -1. So -1i times 4. So -1 times 4 gives us -4. And then we've got the I sitting there as well, right? Now, here's the last one. -1i times positive 3i. So we do the numbers first. -1 times 3 is -3. And then we've got the I times the I, which is I squared. Now, what did we say always happens when you have I squared? We replace it with -1. So this is 8 plus 6i minus 4i minus 3 times -1. And what happens when you multiply -3 times -1? Turns into a positive, right? So this turns into 8 plus 6i minus 4i plus 3. Now that it's written like this, add the real parts. 8 plus 3 is 11. And then our imaginary parts, positive 6i and -4i is 2i. And so that is our answer. Again, in standard form, make sure you put the real part first, the imaginary part second.
So that's becoming more
Okay.
aligned between people who-
Is that making sense so far? Okay. How about this one? Let's do this one. So this is very similar. 3 times 3 is 9. 3 times a -2i, right? So 3 times -2 is -6, and then we've got the I there, right? Then 2I times 3. So again, 2 times 3 is 6. This time it's positive. And then we've got the I. And finally this one, 2I times -2I. So 2 times -2, -4. And then I times I. Now, I could do 3 steps here to get from I squared, right? Because what are we going to do to the I squared? Replace it with -1, and then we multiply, right? What happens every time you multiply -1 by something? Changes the sign, whatever it is. If it's a positive, it changes it to a negative. If it's a negative, it changes it to positive. So what's going to happen right here? This is going to turn into +4. Does that make sense? We don't have to write 3 steps to do that. We just know the sign is going to change. Now we add our real parts. The real parts are 9 and 4. Add those together, you get 13. What happens with the imaginary parts? You see that? A -6i and a +6i are just going to cancel out to be 0i. So they just cancel out. So our answer there, 13. Now before we go on, what do you notice about the 2 numbers that the 2 complex numbers that we multiplied together? They were kind of similar, weren't they? What was the only difference? The sign in the middle. The sign in between those 2, and notice when the sign in the middle is different like that, and the numbers are the same, what happened to our answer? You don't have any, the imaginary goes away, right? That's very important for us, and that's what we're going to be talking about right now. So we get our answer, -8, 11 plus 2i, 13. Okay, we got all those answers. Everybody good with that? Okay. Let's do a couple more multiplication problems here. So this one, it's just 4i distributes through the parentheses, right? I'll let you guys write them down first. So it's 4i times -1 plus 5i. And then the other one is 3 plus 2i squared. Okay. So the first one, we distribute. 4i times -1. What will that be? -4 and then an I, right? So -4i. Then 4i times 5i. What will that be? Plus 20. And then you're right. I times I is I squared. Now, what did we say happens with the I squared? It's a -1. So what does multiplying the 20 times a -1 do to this term? Changes it to a negative. So it's -20, right? Is there anything we can combine? No, so we just need to put it in standard form, right? What goes first in standard form? The -20 goes first. And then minus the 4i. That would be standard form. And just to review, what's the real part? -20. What's the imaginary part? -4. Okay. All right. Now this one, remember that when we square something, you multiply it by itself. So this is 3 plus 2i times 3 plus 2i. Does that make sense? Multiply it by itself. So this is going to look a lot like some of the previous ones we've done. 3 times 3 is what? 9. 3 times 2i is what? Positive 6i. 2i times 3 is what? Positive 6i again. And then finally, 2i times 2i, positive 4i squared. What happens because of that I squared? Changes it to a -4, right? So when we want to put this in standard form, the real parts are 9 and -4. So what do we get? 5? Yes. I heard somebody say that. That's correct. And then the imaginary parts? Doesn't cancel this time because they're both the same, right? So what do we get? 12i.
What do we do?
So notice it's not just that the numbers are the same. The middle sign has to be different in order for them to cancel, right? That's what makes them cancel out. And we're going to talk about that. Are we okay with those two? All right. Get our 2 answers there. We got the right answers. That's good. All right. So here is what we were kind of setting ourselves up for. This fancy word called complex conjugates. Complex conjugates are numbers that look like this: a plus bi and a minus bi. So the number parts are the same, except the middle sign is different, right? One's plus, one's minus. Again, notice the only difference between a number and its conjugate is the middle sign. That's the only difference. The front signs are the same, the numbers are the same, only the middle sign is different. Now, does anybody remember why these are important? What happens when we multiply these together? There's no imaginary part, right? It canceled out. So conjugates are useful because when we multiply them together, the I part goes away. You just end up with the first part squared and the second part squared, added together. Right? Now that's a pattern. You can remember it or not, or you just multiply it. But the middle term will always, the imaginary part will always cancel out. You may see this notation once in a while. Sometimes you'll see a plus bi with the line over it. That means the conjugate of a plus bi. So if you see that, it means a minus bi. Just means that's the notation for the conjugate. I don't know if any of that is in your homework. I don't think it is, if I remember, but that's the notation that you'll see sometimes if you're looking in the book, the PDF book that they have with the lesson. Okay. So this is why we use complex conjugates. Did anybody need that up there still? Are we good? Okay. This is why we use complex conjugates. When we have complex conjugates, we typically will use that to help us simplify division. We don't really divide complex numbers. What we do is we figure out a way to rewrite them in standard form. Okay, and unfortunately, no, we can't just split it up into 2 over 4 and then 3 over 2i. That doesn't work. It'd be nice, but it doesn't work. So here's what we do to put them in standard form. We look at this denominator right here, which is 4 minus 2i. Okay? And we figure out what the conjugate of 4 minus 2i is. So you guys tell me, what is the conjugate of 4 minus 2i? 4 plus 2i. I hope that's what you said. I heard the beginning. 4 plus 2i. Right? Now, if you remember, when we do things with fractions, if we multiply the denominator by 4 plus 2i, what do we have to do to the numerator? Do the exact same thing. So we have to multiply the numerator by 4 plus 2i as well. Okay? And now we distribute. But we have to distribute twice, once on the top, once on the bottom. So on the top, 2 times 4 is 8. 2 times 2i, 4i. 3i times 4, 12i, and that's positive. And then 3i times 2i, 6i squared. And right away, I'm going to look at this, and I'm going to ask you guys, what do we do with the 6i squared? Minus 6, right? You change that sign, it'll be minus 6. Now, in the denominator, when we multiply, 4 times 4 is 16. 4 times 2i, 8i, right? Plus 8i. Now we have negative 2i times 4 will be negative 8i, right, which we know it should be because they're going to cancel out. And then negative 2i times positive 2i is negative 4i squared. And once again, what happens with this negative 4i squared? It becomes plus 4. Okay, so now let's simplify. The real parts on the top, 8 and negative 6, give us 2. The imaginary parts, 4i and 12i, give us 16i. Right? In the denominator, these cancel out, which is what we were hoping would happen. And then 16 plus 4 is 20. We are almost done now. Yeah. Yes. So if you remember that pattern, he's right. We could have just written 4 squared plus 2 squared, which is 16 plus 4, because we know that middle term is going to cancel out every time, and the last term will turn into a positive. That will always happen. But if you're not comfortable with that pattern, just multiply it and you'll get the same thing. Okay? Now we're almost done. Here's what we have to do. We have to split this up. This is the same as saying 2 over 20 plus 16 over 20 times I. Okay, remember how when you add fractions, you have to have a common denominator? Well, here we're breaking apart the fraction that already had a common denominator. And once we've broken it apart, how can we reduce this one? 1 over 10. And then how can we reduce this one? Yeah, we could go even further. It's 4 over 5, right? So what is the real part? 1/10. What's the imaginary part? 4 over 5. So do you see how we really didn't ever divide? We just rewrote it into standard form. Okay, does that make sense? Okay. Now I've got that, and I think I have another problem like this. Hang on 1 second. I realized that I forgot something, so hang on. I'm not going to do this problem. I'm going to make up a problem here for us to do. Because really the point of us doing this section was sometimes we get answers that are not real numbers. Right? Remember how in our last problems we got all real answers? Right? So I'm going to make up a problem here for us, f of x. We're going to find the zeros. Now I have to think about what this is going to look like. Don't look at what I'm doing here. All right, so we're going to have x cubed.
The family tree commanded the independent one, the active one. Here's the picture.
So we're going to find the zeros of f of x equals x cubed minus 2x squared plus 4x minus 8. This isn't a really complicated one, but I just want to show you what happens sometimes when we get answers that are not real. Okay? So let's go ahead and going back, you maybe could think about how to factor this, but let's assume that we can't, and let's go to our p over q, right? Where did the numbers for p come from?
The constant.
Factors of 8, right? And what, so factors of 8. What are the factors of 8? 1, 2, 4, and 8, right? Now, we really like ones like this for the denominator because where do the numbers for q come from? Factors of, what's the leading coefficient? 1. Factors of 1. Well, there's only one option there, right? 1. So this time we don't even have any fractions. What do we have? We have, could be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Right? Those are the only options. Now, one thing I did mention before, because we didn't have any, I don't think, but very seldom do numbers bigger than 5 work. Just doesn't happen very often. So I'm not really going to worry about the 8s unless they're like our last option. Okay, so let's set up our synthetic division. We've got 1, -2, 4, -8. Now again, I'm going to ask us about our shortcut. Is 1 going to work? No, because if I add those up, I don't get 0, right? Okay, so somebody pick a number for us. What do you want to try? Oh yeah, we know 1 doesn't work. Cross that off. And again, these last resort. So I'm down to 5. -4. Okay, let's try -4. So the 1 comes down. -4. That gives us -6. Multiply gives us +24, which is 28. And negative
No.
-100 something, right? It's not going to work. So -4 is going. And that's good. We don't have to go all the way to the end, right? Once we see it's not going to work, we can stop. Okay, so -4 does not work. Okay, then what? -1. Okay. So bring down the 1. You get a -1. That's a -3. Multiply, you get a 3. And 7. And -7. 7. And -15. So that one does not work either. So 1 is gone. Positive what? 2. Let's try +2. Hopefully I didn't make a mistake when I made this. There is hopefully an answer. All right, so +2. Bring down the 1. Multiply, get a 2. Oh, that's a good sign. 2. That'd be 0. And 4. Multiply, we get 8. All right, that one works. So 2 was the lucky winner. Now, what do we have left? This was x cubed, right? So what is this? X squared. So x squared, 1x squared, no x's, right? 0x, and then +4. So our goal is get that x by itself. So what do we do?
Subtract 4.
Subtract 4. So x squared equals -4. Then what? Do you see how we're getting a negative inside the radical there? So we've got x equals plus or minus. What do we have to do with that? Take out the I. And then what is the square root of 4? 2. So we've got x equals 2. Then we've got x equals +2i. And x equals -2i. And those would be our three answers. So one of them is real and 2 are imaginary. Does that make sense? The other time those imaginaries can pop up is if you plug it into the quadratic formula. If this part in here ends up being a negative, does it make sense? That's going to give you an imaginary answer also?
Yes.
Okay.
And the basic idea.
I think what I'll probably try and do is I will try and record one that is a little bit longer like that one, and I'll post that on the Moodle site as just an extra one after the lecture stuff, just in case there's one like that. I can't remember for sure if there's one like that on your homework where you have to use the quadratic formula and you get a negative, but I'll do one like that so that you've seen it. And that's it.